Hi everyone, welcome back to my channel. In this video, I am going to solve surface chemistry CSIR NET previous year questions from 2018, and also I have mentioned 2011 to 2017 video link I have mentioned in description. Please go through that. Now let's move to the question. This question is asked in CSIR NET June 2018. The graph that represents the Langmuir adsorption isotherm is yet four options are given. Now we'll see the solution. The Langmuir adsorption isotherm is given by V is equal to Vm Kp divided by 1 plus Kp, or theta is equal to Kp divided by 1 plus Kp, where V is equal to volume of gas adsorbed, Vm is equal to monolayer adsorption capacity, K is equal to Langmuir constant, P is equal to pressure. Now, analysis of the equation. At low pressure, Kp less than 1. So, V is equal to Vm into Kp. Thus, V directly proportional to pressure. The graph is initially linear. At high pressure, Kp greater than 1. So, V is equal to Vm. So, adsorption reaches saturation, monolayer formation. So, the curve approaches a horizontal plateau. Hence, the Langmuir isotherm is a rectangular hyperbola. Now, we check the options. In option A, they have mentioned straight line graph. There it has no saturation. So, this option is wrong. In option B, they have mentioned S-shaped curve. Type second and third adsorption, not Langmuir. So option B also wrong. In option C, they have mentioned exponential increase. It has no limiting adsorption. So option C also wrong. In option D, rapid increase followed by a plateau. This matches Langmuir isotherm. So the correct option is option D. Now, remember this memory trick. Langmuir is equal to monolayer adsorption, that is equal to saturation, that equal to plateau. In Freundlich adsorption, there is no saturation, that is empirical. In BT isotherm, multilayer adsorption, that is S-shaped isotherm. Hence, for this question, the correct graph is option D. Now, let's move to the second question. This is asked in CSIR in June 2018. The volume cm cube of Cu adsorbed on charcoal 273 Kelvin at two different pressures is given below. Pressure is given as kilopascal 40 and 80, and volume is given in cm cube, that is 25 and 40. Assuming Langmuir isotherm, the maximum possible volume cm cube CO that can be adsorbed is four options given: 50, 100, 150 and 200. Now let's see the solution. In question, pressure P is given in kilopascal, that is 40 and 80. Volume adsorbed given as V, that is given as cm cube 25 and 40. Assume Langmuir adsorption isotherm. V is equal to Vm into Kp divided by 1 plus Kp. Here Vm is equal to maximum monolayer adsorption volume and K is equal to Langmuir constant. In step 1, write equations for the two data points. For P is equal to 40. Now substitute values. 25 is equal to 40 kVm divided by 1 plus 40 K. For P is equal to 80, 40 is equal to 80 kVm divided by 1 plus 80 K. In step 2, use the linear form. The Langmuir equation can be rearranged as P divided by V, that is equal to 1 divided by K into Vm plus P divided by Vm. Now calculate P divided by V. For P is equal to 40, 40 divided by 25 is equal to 1.6. For P is equal to 80, 80 divided by 40, that equal to 2. Now 1.6 is equal to 1 by kVm plus 40 divided by Vm. 2 is equal to 1 divided by Km plus 80 divided by Vm. Now subtract the two equations. So you will get the 0.4 is equal to 40 divided by Vm. Hence Vm is equal to 40 divided by 0.4, that is equal to 100 cm cube. So correct answer is option B, 100 cm cube. Now remember this CSIR NET shortcut. Remember the linear form. P divided by V is equal to 1 divided by K into Vm plus P divided by Vm. Plot of P by V versus P. Slope is equal to 1 by Vm and intercept is equal to 1 divided by K into Vm. Using 2 points, slope is equal to 2 minus 1.6 divided by 80 minus 40, that equal to 0.01 is equal to 1 divided by Vm. So Vm is equal to 1 divided by 0.01 is equal to 100 cm cube. Actually this is the fastest method for CSIR NET exam. Now we'll see the third question. This question asked in CSIR NET December 2018. Langmuir Adsorption Isotherm for the dissociative adsorption of D2. P is equal to partial pressure of D2 and K is equal to ratio of rate constant for adsorption and desorption is, here option E, theta is equal to Kp divided by 1 plus Kp, and option B is theta is equal to K divided by 1 plus Kp, and option C is theta is equal to Kp to the power half divided by 1 plus Kp to the power half, and option D is theta is equal to P divided by 1 plus Kp whole to the power half. Now let's see the solution. In this question, correct answer is option C. Theta is equal to Kp to the power half divided by 1 plus Kp to the power half. Now we'll see the solution. For dissociative adsorption of D2 gas plus 2S gives raised to 2D minus S, where S denotes a vacant surface site. In step 1, rate of adsorption. Since 1D2 molecule requires 2 vacant sites, the adsorption rate is Ra is equal to Ka into P into 1 minus theta whole square, where P is equal to partial pressure of D2 and 1 minus theta is equal to fraction of vacant sites. In step 2, we have to check rate of desorption. 2 adsorbed D atoms combine to form 1 D2. 2D minus S gives raised to D2 plus 2S. Hence, Rd is equal to Kd into theta square. In step 3, at equilibrium, Ra is equal to Rd, that Ra is equal to Rd, that is equal to Ka into P into 1 minus theta square, that is equal to Kd into theta square. Define K is equal to Ka divided by Kd is equal to K. Then Kp is equal to theta square divided by 1 minus theta whole square. Taking square root. Square root of Kp is equal to theta divided by 1 minus theta. Now in step 4, solve for theta. Theta is equal to root of Kp into 1 minus theta. Theta plus theta into root of Kp is equal to root of Kp. Theta into 1 plus root of Kp, that is equal to root of Kp. Therefore, theta is equal to Kp root of Kp divided by 1 plus root of Kp. That is equal to theta is equal to Kp to the power half divided by 1 plus Kp to the power half. Therefore, the correct answer is option C. I hope you understood that concept. Now we have to remember this concept. This is important for CSIR NET. Adsorption type and Langmuir isotherm. For molecular adsorption, that means A plus S gives rise to AS. Langmuir isotherm is theta is equal to Kp divided by 1 plus Kp. And for dissociative adsorption, A2 plus 2S gives rise to 2AS. And for that, Langmuir isotherm is theta is equal to root of Kp divided by 1 plus root of Kp. I hope you understood this concept. In next video I will solve some more previous year questions. If you like this video, please like, share and subscribe to my channel. Thank you. Have a good day.